All right, now that we have the Wild-Walker all completed, now I want to convert it over to mesh. So I broke everything out. I exploded the model and all the parts that I need to have separate for the animatable mesh. And also what would make the baking out the poly more optimized. So like for instance, I have the belly separate. Obviously the cockpit has been, the cockpit placeholder has been pulled out. The back piping has been separated. Yeah, they're back here. That's been separated. Plate for the back has been separated. And the antenna section has been separated. And they don't need to be a part of the bake for the torso itself, since the torso is the most complicated or complex part of the whole form. So I want to have as many polygons to dedicate to that as possible without having to deal with this extra stuff, which can have its own little world. All right, so I make sure that how I do is I make sure that my scene is clean. There are no leftover chunk files. They will be labeled as chunk. Chunk files are left or hidden because the eyeball will be turned off in my scene or anything like that, because that will screw up the overall process. And so I have my bounding box, my bound set up to make my actual bake, and I just try to keep the bound right to the edge. I don't want to waste any space, so I keep it right to the edge of the, I don't have it touch the edge, but I keep it right to the edge of the actual form it's going to be compiling for. Right, keep it nice and clean, as optimal as possible in that particular sense. And let's go on down. Oh, and also just a shout out again to the use of Zen sets. In the overall process, I didn't use Zen sets a lot. I used pseudo. So the making of the Wild-Walker was heavily outline editor for hierarchical stacks. I can't speak today. And pseudo was used for all the selection sets thereof. And so I used Zen, and very little need for Zen sets. But Zen sets is actually critical for me when it comes to breaking the model out to make poly out of it, because it allows me to be able to then take those groups. Then they're labeled out, right? They have call outs and stuff like that. They're color coded. And it's easy. And these hierarchies are slightly, or these, not hierarchies, these selection sets. So the pseudo is more so the selection sets based on the hierarchy, but the selection sets for bake may be slightly different, because there are, once you pull the model apart, you find that there are cutters that, oh man, there's a cutter that cuts, let's say, the ankle, the upper ankle area, but that cutter is actually a part of the lower leg. And so you have to figure out strategically how to get that, if you want to bring that across, whatever. And then it changes in order to maintain that solid form. It'll change what's in that actual selection. Because in other words, that cutter that was fine over here in the upper leg may need to come over here to the upper ankle to initiate that cut, so the upper ankle as a solid object will appear properly, and the way you need it to, before you go to rig it and stuff like that. So it may change. So there may be objects, cutters and objects inside of this new selection set that are specific to what you need for the bake, not what you need for animation, but what you need for the bake. So anyway, and some don't have anything at all. So like this guy here, the upper leg, everything is already hierarchically linked. Everything was like, perfectly, everything that was hierarchically linked was exact to what was needed. So all I needed to do was create a selection set just for the parent of that section, right? So it can vary, and you see that's actually an extreme variation there. So let's go on down. Let's get ready to bake out. Enough of that. We're not dealing with anybody in here anymore. Their job is done. Okay, so let's go mesh poly. Because you'll have to test with your own stuff to see how many polygons are needed to maintain the actual silhouette and form. I found for the Wild-Walker that it's around 50. I call this like the density is like 50% kind of thing. And it captures the silhouette in a great way. And in other words, also like, because if you go lower than that, down to 20, you'll find, let's say if I was doing this upper leg where it has this ribbing, it may drop the ribbing out. It may not capture the ribbing or something. But it all depends. It depends on how big your box is, I think, too. If you're wasting space, then that makes it more difficult. I think that's what also is the case. There's a lot of variables in here. But right now, this is the solid way. So I'm just going to go ahead. Everybody's ready to go. We're going to start with this guy. So we're going to go generate poly, high poly. Then we're going to clean the chunks up. Then we're going to remesh it. And then we're going to put it through its final phase of B-mesh, right? For a final clean. Since it's not going out as STL, if it was going out as STL, I guess I would stop at, it would just be, I would mesh it out, maybe quad mesh it, because quad mesh it, I can strip it down but still maintain the form. So I'd quad mesh it and that would be it. But since it's going to animation, I can strip it down further then. So I use B-mesh, which is a great tool to use for that. So anyway, let's generate the high poly, which is 432. You see them down here, the numbers. Let's go. All right. Now they've been created into chunks. Let's clean those chunks up. We don't want to touch anything. We don't want to mess around with anything. So it's basically all high poly, obviously, and they're all in parts, right? So let's clean this up. This could further be optimized here, but we're just going to go straight with the cleanup mesh chunks. It's going to create one solid chunk form. All right, so the final chunk has been completed, or it's been combined, right? If for those who are interested in chunks, you can see the polys, if you can make them out, right? So it's just one big mass, one big dense mass, right? You can see many polys were generated. You can see much just floating around right now. So let's reduce this down now. Now that it has combined the chunks, we can now remesh it. So using quad mesh. For this structure, I found that 50,000 polys was suitable. I use adapt quad on because they have there's so many concave and convex little areas throughout all this stuff that I don't want to spend time baking out and then it not capture it. So I have that on now. Everything else is just let roll, and let's just remesh it. And when it remeshes it, it's going to, the thing that needs to be noted, quad mesh will generate its own mesh, and it's going to hide the chunk. And I'll say why this is important to remember later on. Remesh it. Okay, so now it's actually remeshed. Quad remesher has remeshed the chunk, and it's hidden the chunk. So this is the issue, not an issue, it's just something to be mindful of. Let's move our remesh chunk. Let's just move it out the way here, off of the, wait a minute, not that. Let's just move it away from the SDF. and the chunk. See, the other chunk is empty out right now. And wait a minute, let's turn on wireframe. Okay. So this is the quad remeshed version, right? And it's 140, was it? 132,000 faces. Okay. Compared to the millions of faces in the chunk. So that works out, that starts to work out great. I'm looking at my divisions here because none of this is using subdivision surfaces in the end. So I need a certain amount of polygons. These can be reduced a little bit, but it doesn't really matter because they're not being deformed. But I need at least this amount of polygons to create the curve or the indentations here. So that's fine. I'm about to strip it down further. But the thing about the chunk is the chunk stays hidden. It's great because it allows you to keep work. You know, if you want to come back to the chunk and strip another one out and stuff like that, especially if you're testing. I'm not in the testing mode right now, so I'm literally going to finals on these. So I know I've already tested and figured out that 50,000 is great for the quad, for the limbs, and I've already created my my preset for B mesh that cleans the mesh up the way I need it to. So why I say all that is because I need to go back to the chunk now, because I need to go back and either rename this chunk, right? So that's what I'm going to do now. I don't want to leave it as that same base name, because when I go to bake out the rest of these forms, when they create their chunks, they're going to use that same naming convention. And I found that, at least in my case, I found that actually screwed up the chunk making process. So it either has to be deleted or renamed. Since I already been through this, since I already know what everything's supposed to be set at, I'm just going to go ahead and delete it. So I'm not going to be redoing that leg. And so that's the original chunk, and I'm just going to delete it. And so it's important to know that, because it actually, once again, Quad Remesher hides it, right? And so if you don't have your outline editor set like this, and you're looking, you won't see it in your scene, and so you're like, oh, okay, it doesn't exist anymore. And all of a sudden, when you want to bake out another piece of geometry in that same scene, then you'll find that maybe you're running into errors. So now here's my my nice quad mesh one, right? And it's going to see Quad Remesher titles it like retopo chunk, right? Retopo whatever it was, whatever the original title of it was. Okay, and so we're just going to go down now. I'm just going to save, because I don't want to sit there and bake out again for any reason, even though I haven't had Conjure crashing and during the baking processes or anything like that, which is great. So this is my setup with B mesh, and so I want to strip. I want to get rid of whatever polygons are useless without damaging the form. So we're just going to hit it. All right, and so these are all the polygons and everything that it's reduced it down even further to. So yeah, wow. Now it dropped it down to 108,000. It's now 108,000 polygons, right? And so all those open areas are no polygons. This is not an optimized view. This is actually what BMesh just did to it. But then I hold on to a lot of these areas that I normally would use subdivision surfaces on top of a form to try to make sure maintain the curvilinear aspect and everything. These areas have held on, right? And I tested it in renders and everything already. So I did a lot of testing back and forth to make sure that these settings from BMesh that I have set up now would be the most optimal. And just a quick eyeball on the upper leg. So I usually use Modo to do any type of inspection of geometry and stuff. And so here, we have the wireframe on, so you can see even more so how B-Mesh simplified the form and what was held on to from the SDF. All right, so you got nice, impossible, impossible forms, or well, not impossible forms, but beautiful welds, beautiful mergers between the form, and all that it held onto here. Now, once again, none of this, all this is just as it is. It's not, no subdivision surface is going to be applied. There's no need to do anything like that. And let's just turn off. And so then we're left with this. So the part is nice. No complaint. Just got a little overlap here that can be fixed, but everything else nice and clean. All right, ready for animation. And let me see. Oh, it'll tell me right here. Don't do that. Modo is telling me so I have 113,000 polygons in here. Okay. All right. Okay, so now that we have the model meshed out and some adjustments made, which were important, let's go ahead and start to assemble this. So first thing I'm going to do is I need to separate everybody. So let me see. I've already started with already got the upper leg, and now let's do let's do the lower leg. Oh, I can just, I already did Pete. All right. Oops. Nope. And who else? So these guys are done. 1, 2, 3, 4. And anybody up here? And these guys stay as a unit. This stays as a unit. All right, that was simple enough. Okay, and the very first thing we do is we're going to start bringing let's bring in the